Okay, here begins part 4 of the section 4.2 homework. We're picking it up on number 18, and I'm hoping to do the rest of the problems in this video. Once again, it's saying to show that, basically apply the mean value theorem to number 18. So the first thing they want us to do is verify that it's continuous and differentiable from 2 to 4. And natural log graph is continuous, so that shouldn't be an issue, especially in this region of 2 to 4. Is it differentiable between 2 to 4? That becomes the derivative is 1 over x minus 1. So if we were going to plug in 1, we'd have a problem because it wouldn't be differentiable at 1, but we're only looking from 2 to 4. So again, I haven't really shown any math to verify, but I have considered it and talked it through, and so I consider part A satisfied. So now part B says find the value of C that would give us the where the instantaneous rate of change is equal to the average rate of change. So first thing I need to do is find the average rate of change. So I've got f of 4 minus f of 2 over 4 minus 2. So that's going to be the natural log of, plug in 4 as 3, minus, plug in 2, I get the natural log of 1 over 2. The natural log of 1 is 0. So really what this simply becomes is the natural log of 3 over 2 is my average rate of change. And we might put that as a decimal in a minute, but for now let's just leave it alone. So this is the average. That would be the slope. Again, if we were to graph natural log of x minus 1, that has an asymptote at positive 1, and the graph looks about like this. So they're saying from 2 to 4, we've found that the slope of that line is the natural log of 3 over 2. Now I'm looking for what I approximate to be this point, where the average rate of change, or the instantaneous rate of change at that point would be the same as the average. So in other words, I take my derivative and I set it equal to the average. So I get the natural log of 3 over 2 equals 1 over x minus 1. A little cross multiplying here, I get x minus 1 times the natural log of 3 equals 2. And then I will divide by the natural log of 3 because it's just a number. And then I'm going to add 1. And whatever that x value is that value of c. It is this x coordinate, or the derivative at the point, is equal to the overall rate of change. And that's what it's looking for. Okay, so now we switch gears a little and we go to problems 25 through 34. And I'm not going to be doing all of the problems. I've written out the ones I'm going to do. And it says, for the first section, find all possible functions with the given derivative. In other words, I need to find what's known as the antiderivative. So the antiderivative is the function whose derivative has been given to you. So in other words, we need to move up a level. If you think about, you have function at the top, you have its derivative below that, you have the second derivative below that, etc. We're starting here at the first derivative, and I want to move up. So I just have to undo the rules. So that means if my derivative is x, then it had to have come from a function where the power was, I'm going to leave myself a little room, x squared. But if I take the derivative of this, that would give me 2x to the first power. And I don't have a 2 in front of my derivative that they gave me. So what that means is that 2 must get canceled out somehow when I bring it down, which simply means I should have a 1/2 in front. Now when I bring the 2 down, 2 times 1/2 is the 1x that I'm looking for. So this is pretty much the answer. There's one extra piece to add, and that would be I have to find all of the possible functions that would satisfy whose derivative would be given by x. And so what that means is any constant attached to it that function would still have a derivative of x. Alright, so then that's my answer to 25. So I'm going to jump over to 28, and again, I'm looking for the function that when I take its derivative, I get sine of x. So then for me, it seems obvious it has to be some version of cosine of x. And so I'm going to stop, and I'm going to make a guess, and I'm going to take the derivative of cosine, which gives me negative sine. I don't have a negative sign, so that must mean, again, I have a constant out front. So now when I take the derivative of cosine, I get negative sine, but now I have a double negative, which makes positive. And again, plus c to get the entire family of functions. Number 30, once again, it's just a matter of figuring out what function has this as its derivative. And this is kind of a tricky one. Because usually we're thinking in terms of power rule and that sort of thing. So some of us might look at this as, let's rewrite it, and the derivative is x minus 1 to the negative first power. So again, thinking about the function that would have this as a derivative, we need to add 1 to the power to undo the subtraction of 1 that we would have used to get this derivative. But if I add 1 to the power, then that gives me, not f prime, but f of x would be, I don't know, something like to the 0 power, which is just 1, which wouldn't have a derivative of 1 over x minus 1. So what we found here is that thinking of this as a negative exponent doesn't seem to really work out. Alright. In general, that's a good idea. You know, let's just do a quick timeout. If I was going to take the derivative of, or find the antiderivative of 1 over x squared, then that method would work great. I'd rewrite the problem as x to the negative 2, and so then the function would be add 1 to the power, it'd be x to the negative first, take the derivative, and I would have a negative, which I don't have in this function, so it would be this. So it works just fine, but the problem is on this one, since it's the negative first power, if I move it up, I go to 0. And this is a long explanation for me to simply tell you that when that fails, when that negative exponent fails, that should be a reminder that this is an unusual one. And the answer is simply, if you think about it, the natural log of x minus 1. Because the derivative of natural log of x minus 1 would simply be 1 over x minus 1 plus c. So, in general, writing as a negative exponent is a good idea, but if it's just to the negative first power, like our problem is, then it's not going to work. Oh, that was unfortunate. Let me fix my zoom here. Or not. Hold on a second. Don't know what I hit to do that. Okay. Alright, so now let's do this last couple of these. Let's get rid of this gibberish. Probably my conversation here didn't help at all on that one. Okay, but maybe we can see it in action on this one. So I'm going to rewrite the function as 1/4 x to the negative 3/4 power. So this section is saying still find the antiderivative, but this time find the very specific one. In other words, instead of putting a plus c, we're going to try and solve for what the specific constant is. But the first step is still to figure out the antiderivative. Alright, so what I'm going to do is I'm going to start with the x to the negative 3/4. And I know that I need to add 1, and so adding 4/4 would be x to the 1/4. So I'm going to stop there, I'm going to test it. 1/4 comes down, subtract 1, and I get exactly what they have here. So my constant works out fine, and this would be the family of functions that has this as its derivative. But this time, they've given me an x and a y value, which should allow me to solve for this specific c. So f of x, the output is negative 2, the input is 1, so I get negative 2 equals 1 plus c, or c equals negative 3. So the answer to the question is 1/4, let's just write it over here. F of x equals x to the 1/4 minus 3. So this is the very specific function whose derivative would be given by this, and who satisfies the point 1, negative 2. Okay, so 34 is asking the same thing. I'm going to have to stop this video, I think, in a second. So once again, let's take the antiderivative, term by term. 2x becomes x squared with a 1/2 in front to cancel out the 2, plus x, because the derivative of x is 1. We have negative cosine of x, so the antiderivative of cosine is sine. So I'm going to put minus sine of x, and let's test the derivative. 2 comes down, cancels out. The derivative of x is 1. The derivative of sine is cosine, so we get minus cosine, plus c. And now once again we have an x and a y value. So I have 3 equals, plug in 0, plug in 0, plug in 0 for sine. Sine of 0 is 0, so I simply get c equals 3. So my answer is 1/2 x squared plus x minus sine of x plus 3. And again, this is the function. When I take its derivative, would be what they gave me. And if I plug in 0, 3 into the original function, it works out. I want to go back and check something real quick. I feel like maybe I made an error right here. Let's just double check. The derivative of cosine is negative sine. Okay, good. Nope, it works out. I'm going to stop this video and we'll pick it up and finish with the next one.